Okay, hello everyone. This time we're going to do a linear programming with integer and binary constraints. So we have a problem here with a firm that offers four different training packages. Okay, there's associated fixed cost with the packages, and there's also the cost per person. It's given here. And there's also maximum enrollment for each of the training package. So training package 1 can help an employee develop skill A, C, and D. 2 can help the employee develop A, B, and D, and so on. So this thing is shown in the table. Now, what we want to do is we want to minimize the cost, okay, by determining which training packages to offer, subject to the following constraints. Okay, so the constraints are that one constraint is that at least 100 employees should have skill A, and then 120, 110, and 95 employees should develop skills B, C, and D respectively. Okay, so we put the data in here, right? Okay, so the first thing that we have to develop is an index. Okay, we let I to be the index for the training packages. Okay, so its I will be 1, 2, 3, 4. So yi will be 1 if package I is selected, 0 if not. So this is the y1, y2, y3, y4. So yi is a binary. Okay, it's 0 and 1. And xi is the number of people in training. Okay, so xi will be integer, right? So 0, 1, 2, 3, and so on, with integer values. All right, so we want to know the minimum cost of the minimum cost that will satisfy all the constraints. Okay, so the first thing is this: we are going to develop the common sense constraints. Okay, so the common sense constraint here is that if xi is 0, yi must be 0, right? If you're not going to produce any, if you're not going to have a trainee on the package 1, then you're not going to offer package 1 altogether. That will make you avoid the fixed cost. So how do we say that? So we say that yi must be less than or equal to xi. Yeah. So when xi is 0, right? Because yi is less than, so yi has to be 0. Okay. Now the next constraint is that when xi is a positive number, yi must be equal to 1, meaning you'll have to offer the package. So remember that there's a capacity constraint on xi. So how do you incorporate it in here? So we say xi must be less than or equal to the capacity of I times yi. Yeah. Okay. So the capacities are here, right? So the maximum enrollment. Okay, so I'm gonna call this CI. Okay. So C1 is 50, C2 is 70, and so on. Okay. So this is going to say that when xi is a positive number, yi should be 1. Yeah. Okay. Yi should be 1. So that is that's a skill that you have to develop. So this one says that if xi is 0, yi must be 0. Okay. Now the minimum cost will be the fixed cost times the yi, right? Okay. So you'll incur the fixed cost if you offer the training packages, and then the unit cost, okay, per person cost times the xi. Yeah. So we just simply say it's just equal to some product of the fixed cost with yi plus sum product xi times the unit cost. Okay, and we also want to incorporate this thing that says that yi is less than or equal to xi, so we can do that later. Okay, and then we also have xi is less than or equal to ci times yi, so we need to have ci times yi. Okay, so there. Now the next one is fairly easy, the one that says you need to have 100 people that must develop skill A, and skill A is offered with training 1, 2, and 3. So that means, x1 plus x2 plus x3 must be greater or equal to 100. And, 120 people must develop skill B, and so on, right? So let's just put this in. x1 plus x2 plus x3, x1 plus x2 plus x3, okay, must be greater than or equal to 100. This one is x2 plus x4 must be greater than 120. Okay, these are all greater than or equal, so let me just copy this. This one is x1, x3, x4, so x1 plus x3 plus x4, okay, must be greater than or equal to 110. And this is x1 plus x2, x1 plus x2 must be greater than or equal to 95. Okay, now yi is binary, xi is an integer greater than 0. Now we are ready to put this in a solver. So we do okay, data. Okay, we click data and then solver. Right, so let's reset this. Okay, so what we want to do is we want to minimize the cost. Cost is this one here. Okay, by changing the variable cells. These are the decision variables, and the constraints first is that yi is binary. Next is that xi is an integer, okay, and then next is that xi is less than or equal to ci times yi, that, and then the next one is yi is less than or equal to xi, so yi is less than or equal to xi, okay, and then these numbers here, the minimum should be bigger than the required here. Okay, so that's it, and then we click solve. Oops, could not find a solution. Why is that? Let's see. What is the problem now here? Maybe where's this? This is not just because I was doing it with a different sheet. So here we want to minimize B31 by changing B22 okay to E23. That's correct. This one says B22 to E22 is less than or equal to B22 to E22. Yes, it's less than or equal to B23. So it's this one here. This one says that. Okay, so this one is the xi is 0, yi is 0. Yeah. And this is binary. Okay, so The yi is binary, should be 8, and then the x. Oh, I see this one here. Okay, it should be integer. B22 to E20. B23 to E23 should be integer. And then this one is C38 to C41. C38 to C41 must be greater, and that should be fine. Alright, so let's try a different thing, maybe simplex. Okay, so I'm gonna reset this. It's not picking up that I want this to be an integer. I want this to be a binary, 601, and this one should be an integer. Okay, so let's do again with the syntax. Let's find the solution. Well, this one is the solution. So okay, this one is the x1 plus x. I see that way. So x1 plus x2. I mistakenly put it as y1 plus y2. x1 plus x2. All right. So there. Right. Okay. So I saw the simple mistake. So we do this again. Okay. Now it's found a solution. Okay. So there's really no problem. Even if I start with this one is nothing. Okay. I'll solve it again. Now it will find a solution. Okay, and that's the solution. The earlier mistake is that this one was like pointed to y1 and y2, not x1 and x2. All right, so now this is the solution to this problem. So the main takeaway here is this constraint here. Okay, so this constraint here says that if xi is 0, okay, if you do not have a trainee on any one of the package, then don't offer the package. Yi must be 0. This one here says that if you're going to offer, if you have a trainee in any of the packages, then yi has to be 1. Okay, yi has to be 1. So because it's like, and xi, and this one also means that xi cannot exceed the capacity. Okay. And at the same time, yi cannot be 0. It should be 1, right? Okay. So that's all there is to this session. Contact me if you need anything else.